not that one. Oh goodness, my apologies. Wrong button. There we go. Today we are starting book number 3. So it's our last book. This is going to take us to the end of the year. We are starting off with Unit 7. Unit 7 has to do with different geometry topics. Some of this we might be familiar with from 5th grade. Some of it is going to be brand new. Voices need to be quiet. Eyes should be up front. We are starting today with CO51. There we go. CO51. I can measure, draw, and classify angles using a protractor. That is what I just passed out to us in class. So this is called a protractor. Not sure why my pen is not working. I love Mondays.
So do I.
Oh, goodness. Yep, not sure why. Let me see if I recalibrate, if that helps. Okay, let's see if now it'll work. So this, oh, we have too many boxes. This little doohickey, this tool on our page is called a protractor. What do we use a protractor to do? It measures angles. So we can find what do we measure angles with? What term do we use? When we use a ruler, we're using inches or centimeters. For angles, we do degrees. So Cameron and Liam, we talked a lot in religion about respect. That is our virtue of the month. And I said, do not forget to show respect to one another and to our teachers. So when you are being goofy across the classroom while I am trying to teach, that is not showing me the respect that I deserve. So I would appreciate your eyes up front, focusing on that now, please. Our protractor measures the degrees of our angles. So with a ruler, it could be inches, it could be centimeters, it could be different types. Degrees are degrees are degrees. Everybody uses the same measurement around the world with degrees. We will notice how it measures from 0 to 180 in both directions. So we can see on the left side, 0 is on the outside, and it goes all the way to 180 down here. I'm trying to show us with my pen, but it keeps clicking on the boxes. But we can see on the outside, it goes 0 to 180 from left to right. On the inside, we start at the right-hand side, and we go to the left. Why do you think it goes in 2 different directions? Why does our protractor, why can we measure in 2 different directions? Melanie? That is a really good guess. That it's negative or positive, but here's the thing with degrees. There are no negative degrees that we're going to use. It is a full circle. But why can we measure to the left and we can measure to the right? Why do you think, Claire? I'm sorry, what? Yeah, 180. So if we look at your protractor, that's 90. You have to go all the way over. Yours is ending at 170 is our number, but it keeps on counting. Because we know it goes to 180. It just didn't write it. So this line down here would be 180. So some of our protractors, what Claire noticed, good thing you were paying attention and you heard me say 180. The picture protractor shows that final line at the very bottom to be 180. But on some of the protractors, the class set that I have, it stops at 170, but the lines keep going after. And it goes to 180. They just didn't write it on there. So you just have to keep on counting. Okay. Look over on the right-hand side. We have some angles. Is it gonna let me write over here? It is not. I don't know why it's not letting me write. So we have some angles that open up to the left, some angles that are the opposite way. So it depends on which direction your angle is going as to which part of the protractor you're going to start with. So when we start to measure, we have to pay attention to where that angle point is. So when we line up my protractor, I have the big, huge yellow one. I'm going to put the angle point, that vertex, I'm going to put it right in the middle of my protractor. And I'm going to look at which direction, oh my, I can't press down hard. That line on the bottom of my angle is going to the left. That's where I start with my 0. Okay, so if I line up that center part of my angle to the center of my protractor, I follow my line. If it goes to the left, I go to the 0 on the outside. And I'm going to count up to where that top line is pointing to on the outside. On the bottom angle, if I put that center point in, it's pointing to the right, that bottom line. That's where the 0 is on the inside. So I count up on the inside to where that top line is pointing to the protractor. So does it make sense why we have some on the outside and some on the inside? It depends on which way our angle is pointing to. So we have some vocab words to put in. I am going to, because my pen is not working for whatever reason, I'm going to write it under the document camera. Layla, can you go get me one of the small protractors from the back so I can show it on the document camera? So I am shifting gears from doing it on the board with the smartboard to doing the document camera. So our first key term that we're going to write in is the vertex of an angle. Thank you. The vertex of an angle is the point where the two sides of an angle meet. So when I look at this angle here, I've got one side, I've got the other side. That vertex is where they meet. On the bottom angle, I've got one side, I've got the other side. Where they meet is my vertex. That vertex is what I put in the middle of the protractor. Now we have different types. So using the protractor, you would line it up like this. Line up that bottom line. I can see it's pointing to the 0 on the inside. Now it doesn't have a 0 listed, but I know 40, 30, 20, 10. I know the 0 is going to be right here. So that means I'm going to use the inside numbers counting up to where this hits. And if I'm on the top angle, I can see it's pointing, this line is pointing to the 0 on the outside. So I count up on the outside to where this line is going to hit it. We're going to go over that more as we go through this page. But first we need to understand all of our different terms. So there are different types of angles. Our first angle type is the acute angle. Who remembers what an acute angle is? Marina. Yeah. And I like to say acute, it's a little cute and tiny. What angle measurement does an acute angle fall in? There's a range, Melanie. It's going to be less than 90 degrees. So an acute angle is an angle with a measure of less than 90 degrees. And you make that little degree mark for your measurement so we know that it means degree. So you have to put your little degree symbol in. So when we look at that protractor up here, here's our 90, here's our vertex. So we can see 90 degrees comes straight down and over. So an acute angle is going to be smaller than that. So an example of an acute angle might look like this. It could look really tiny like that. It could look close to that 90 degrees, but it cannot be 90 degrees. Why can it not be 90 degrees? Layla? Connor? That's a right angle. A right angle is an angle with a measure equal to 90 degrees. It's exactly 90 degrees. Not 91, not 88, exactly 90 degrees. So when we draw a right angle, they all look the same. And I'm going to put this little box in there. That box that I put right at the vertex tells me it is exactly 90 degrees. So sometimes you'll see them write that it's 90 degrees. Sometimes you'll just see that little square. That little square tells us automatically it's 90 degrees. Now my 90 degrees could go that direction or it could go this direction. Doesn't matter which way it's pointing. It's still 90 degrees. If it has the little square in it, we know that's the same as saying 90 degrees. So whether it writes 90 degrees or you put a square, same measurement. Then we have an obtuse angle. What is an obtuse angle, Marina? It is big, but you have to be more specific than that. Dom? So look back to what we put for acute angle. We said an angle with a measure of less than 90 degrees. So more than 90 degrees. So an obtuse angle is an angle with a measure greater than 90 degrees. So an example of that, it could look like this. Try to make your line as straight as you can. It could look like this. It could be facing either direction. It's still obtuse because they are bigger than 90 degrees. They are bigger than that right angle. So as long as it's bigger than the right angle, it is an obtuse angle. So its measurement could be 175. It could be 92 degrees. As long as it's bigger than 90 degrees, it is obtuse. Layla? It has a vertex where the two sides meet. So yep, every angle has that vertex. So you said a dot. So every angle has a dot. So we look at our angle, you'll see a line like that for the acute saying what angle measurement is. So let's say this angle measurement might be 50 degrees. Here, our angle measurement might be 160 degrees. So that line is telling us what angle we're talking about. Okay. So every angle has a vertex. And when you see that arc that's inside of our angle, it's telling us which angle we are talking about. Okay. And the 90-degree angle isn't going to have an arc. It's going to have the little square box. Our last angle we're going to talk about today is called a straight angle. What do you think a straight angle is, Jimena? Shh. Look at our definitions for all the other angles. We're talking about degrees. So what do you think? Jimena's right. A straight angle is a straight line, but give me a definition in degrees, Jimena. An angle with, oops, I forgot to write angle. An angle with a measure of 100 or equal to, with a measure equal to, just like the right angle was equal to, the straight angle is equal to 180 degrees. So we've got our vertex, we've got one side, and we've got the other side, and it makes a full 180 degree angle. So we've got 4 angle types. We've got the acute angle, which is cute and little, so it's going to be smaller than 90 degrees. We've got our right angle, which is exactly 90 degrees. We've got an obtuse angle, which is bigger than 90 degrees. It's greater than 90. And then we have our straight angle, which is exactly 180 degrees. So it is that straight line. So now we're going to look at measuring with that protractor. So if you are at home, or you know you don't have a protractor at home, you can ask to borrow one of the classroom set protractors. Or if you have one at home, you do not have to go out and buy one, because we are not using these that long. Okay, so it's just for a couple of days. I have a whole class set. It's okay if you want your own, or you already have your own. Can you wait until I'm done recording? Because I don't want you to miss the lesson. So you don't have to go out and buy one. You can borrow one from the classroom. It does have to be returned back to the classroom bucket, because I use these every year. If you want, or you already have one from home, bring it from home and you can use it. Okay, they're all the same. They might look slightly different, just like rulers can come in different colors, different materials to make it. Mine is an orange one. You have clear ones. They're all the same though. They measure exactly the same, just like rulers measure exactly the same. So here's my protractor. So it's a little bit bigger than the one that we have on our page. It says to measure an angle, please don't play with the protractors, because it's very distracting as I'm trying to teach. To measure an angle with a protractor, you're going to position the vertex of the angle at the center of the protractor. So if I look at my example here, is it easy for me to put my protractor here? Why not? No, because I have my binder is kind of in the way. So you can take the page out of the binder. Nothing says you have to keep it in there. You can take it out to make it easy to work with, and when you're done, put it back in. So I'm going to take it out so I don't have that ring in my way. So now I can move my paper down. I can put my protractor exactly how they put their protractor. This is the important part. Notice how my protractor has a line that goes to where that open spot is, that open circle. You're going to want to not only find the vertex of your angle to put in that open circle. Look at what happened. My line doesn't line up with my angle line. I want to turn it so the line on the protractor is exactly over that angle line. So you can see the angle line is as close as I can get it onto the protractor line. So the angle and the protractor line should line up. Your vertex should be as close to the center of your circle as possible. And then what you do, if you have your center here, my line is pointing to the outside 0. So then I want to look at the top line of my angle, and I'm going to see where that's pointing. So they drew a dotted line. I'm going to continue that dotted line up to the outside. My 0 is on the outside, so I need to go up those outside numbers. And I am coming to, looks like right here, which would be 45, 46, 47. So I am getting 47 degrees. If I look at the one that they did on the paper, it looks like it's pointing to the 45 on their protractor. So they would write 45 degrees. Here's the thing working with protractors. Is it always precise? No. I got 47 degrees, and on the paper protractor, it looks like it's 45 degrees. I will accept a small range for degrees. 45 to 47 is only off by 2 degrees. I will not accept you saying that this is 50 degrees. That is too far off. That means you did not line your lines up well enough. 50 degrees is way up here. So you have to line it up close enough so you get very close to where it needs to be. Another way you can do it is you can continue that line. Oh, I see where my difference kind of came in. If I use my protractor as a ruler and I continue that straight line, now look at what happens. When I continued the dotted line, I got off a little bit. But when I used my protractor as a ruler, I can be even more precise because now look, I continued my line and now it looks like it's between 44 and 45. I'm even closer. So what I would do when you're using your protractor is not just eyeball it or kind of draw the line yourself. Use that protractor to draw a longer line. Use it like a ruler to continue that line up. So when we go to measure it, we're going to line it up. The vertex of your angle right in the middle. You're going to line up that bottom angle line to that line on your protractor. I see here that I'm pointing to the inside numbers. I don't have a 0 listed right here, but I can see 10, 20, 30, 40. So I know that this is the 0 side, even though it doesn't list a 0. So you can visually do it, or you can actually draw the line up so it'll fit. Now I'm going to go up 0, 10, 20, 30, 40, 41, 42, 43, 44, 45 is a little bit bigger, 46, 47. So this is 47 degrees. Ava, did you have a question?
Yeah, have you
Do you have a line on your protractor? On your plastic protractor. So you're going to put the vertex, that center point, you line that up right in the middle of that circle. And you can see here the line on my protractor does not line up with that line of the angle. So you want to move the line from your protractor right on top of the angle line. And make sure that as you're moving it to line it up, you keep that vertex right in the middle circle. So you do have to pay attention to how you line it up. So not only are we going to write our angle measurement, measure each angle, and classify it. So if my angle measurement is 47 degrees, what would I classify this angle as? Acute. There is no 45-degree angle. It is an acute angle because it is less than 90 degrees. So not only do I put my degree measurement, I label it, I classify it. Acute, right angle, obtuse, or straight angle. This is just this page that you have to work on. So what we're really working on is precise measurements. We have time in class. Do not rush your angle measurements. If you're not sure, like Ava was asking, how exactly do I do it? If you're not sure you're doing it right, bring it up to me and I'll help you measure it correctly. If you are watching at home, I hope you are well. If you do not have a protractor, come borrow one from me. So you have one to work with on these pages, and then make sure you return it. So I hope you are well. I hope to see you soon. Have a wonderful day.